In this video, we're going to talk about the midpoint of line segments and learn what line segment bisectors are. The midpoint of a line segment is basically what it sounds like. It is the center point of a line segment, and it splits the line segment into two equal segments, two equal halves. In this case here, point B splits line segment AC into two separate equal segments, segment AB and segment BC. Since those two segments are equal and have the same length, that means that they are congruent to one another. So we can put our congruence marks in for those. Let's say that we're told the line segment AB has a length of 5. Then we'd also automatically know that line segment BC has a length of 5. And then we'd add those two to get the total length. So 5 plus 5, 10, to get the length of AC. Now say we're told that AC has a length of 12. We would just divide by 2 to get the lengths of the two segments. So 12 by 2, we'd get 6. So that would mean AB is 6 and BC is also 6. And we'd always divide by 2 to get that information because that total length is made of two segments. Now all that a line segment bisector is anything that crosses it at exactly the midpoint. So anything that splits it into two equal halves. Let's say we have a line here and it goes exactly across point B. That would be a line segment bisector. It could be any direction, perfectly straight, any other direction, and it is still a segment bisector. What matters is that it splits line segment AC into two equal halves. Same thing with a ray. It could even, the ray could even start right at the midpoint. It's still splitting it right there, or go further in. But yeah, that is a segment bisector as well. Even planes can be line segment bisectors. Here's an example here. The plane is cutting this line segment into two equal halves, so it's a bisector. And that plane, again, could be in any direction. Now let's say we have two equal line segments that are bisecting each other. So in this case, we have line segment AC and line segment HI that are bisecting each other basically, and that is occurring at point B. And since they're all equal length, all four line segments that we have there are congruent. So say we're told that line segment HB equals 35, we would automatically know that BI, AB, and BC all equal 35. And then we could do 35 plus 35 to know that the line segment AC equals 70 and that line segment HI also equals 70. Let's look at just line segment AC again. And say we aren't told that B is the midpoint, but we're just told that line segment AB is 12 and line segment BC is 12. Since those are the same, we know that those are congruent, and then we would know that point B is the midpoint. All right, I'm going to remove these one more time, and let's do an example with algebra. Let's say we're told that line segment AC has a length of 16, line segment AB has a length of 7, and line segment BC has a length of x plus 4, and we're asked to determine whether or not point B is the midpoint of line segment AC. This is a good point to pause for a second and think about it. In this case, we wouldn't actually even need to solve for x. And that is because we know that in order for B to be the midpoint, it needs to split the total length into two equal halves. Since we know that total length, we can divide it by 2 to figure out what the lengths of those halves are. So 16 divided by 2 is 8. Each of those halves would need to have a length of 8. And we already know that line segment AB has a length of 7, and that means that B could not be the midpoint. Let's look at this situation here. We have line EF crossing line segment AC at point B, and all we're told is that AB has a length of x plus 3 and BC has a length of 9. And then we're asked what value x needs to be in order for line EF to be a segment bisector of AC. So let's break this down a bit. EF is going to be a segment bisector of AC. It needs to cross exactly at the midpoint, which means that AB and BC have to be congruent. They have to have equal lengths. So we can set those two equal to each other's. We have x plus 3 equals 9. Subtract 3 from both sides, and we get that x would need to equal 6. Plug that back in, so 6 plus 3 will give us 9. and then AB is 9, so yeah, 2 equal lengths there, and that makes it a segment bisector. In our next video, we're going to take the information that we've learned so far and learn how to write a proof.